Welcome back to 6-Minute Tutorials. Today we're going to be looking at an example of a related rates problem. So we're given that a rectangular bathtub has a base of 18 feet squared. And the first part of our question is, how fast is the water level rising if water is filling the tub at a rate of 0.7 feet cubed per minute? So let's see what we're given, okay? We're given a rectangular bathtub, which is pretty much a rectangular prism, which would look roughly like that. I'm not the best artist, so let's just imagine a stretched out cube. Okay, it has a base of 18 feet squared. Notice the squared that defines that 18 feet squared is our the area of our base, because we're even told it's base. So we know the area of the base. How fast is the water level rising? So we need to find the rate at which water level rises. And water level would be translated as height. We kind of need to understand that. So we will write this as dh dt, which means the change in height with respect to time. All right? And what else are we given? If water is filling the tub at a rate of 0.7 cubic feet per minute. So here we're given feet cubed, and that represents volume. And we're also given per minute, which means this is probably one of our dynamic equations. If you don't know what a dynamic equation is, take a look back at the previous video where I talk about static and dynamic equations. We also know this is dynamic because we're told it's water fills the tub at this rate. So because we know this is cubic feet, this has to be the rate at which volume is being filled with respect to time. So we could write dv dt equals 0.7 feet cubed per minute. And we know the area of the base, which we will show as capital B, is filling the tub at, capital B is just 18 feet squared. So if we were to show a static equation for the volume of a rectangular prism, we would know to say length times width times height. But because we're already given the area of the base, we know that length times width is simply big B, or 18 feet squared. So these are the same. And we'll just have our times height. Now we should take the derivative of this equation. So we have V equals B times H, and we're going to take the derivative of this equation with respect to time. So we're going to have dV dt equals, we're going to have to use product rule now. So the base is not going to be changing. Well, okay, let's take the derivative first, okay? And then we'll talk about the different parts. And I should not be representing these as prime. So dB dt, and if I just move this over, dH dt. So, okay, this is the next part of the problem, which I do not want to see right now. So as we're pouring water in, we know that the base is not changing. So if the base is not changing, this value, dB dt, is 0. 0 times h is just 0, so this does not even matter. So now we have b, which we know is 18 feet squared, and we have dV dt, which was given to us as 0.7 feet cubed per second. So what we can do now is, if I just move this up so we have room, plug in our values. We will have 0.7 equals 18 times dH dt, and because we are looking for the rate at which water level rises, we just have to solve for this, dH dt, which means we're going to divide both sides by 18, and that is our answer, 0.7 over 18. And if you simplify 0.7 divided by 18, you get 0.0389 feet per minute. You know it's feet per minute because originally here, where you had 0.7, 0.7 was in feet cubed per minute, and you divided by 18, which was in feet squared. So the feet squared and a feet squared from the feet cubed cancel, giving you 0.7 over 18 feet per minute, which is, once again, this right here. So the second part of this question is now asking, at what rate is water pouring into the tub if the water level rises at a rate of 0.8 feet per second? So if water level is rising at this rate, this is our dH dt, because this is the height increasing, or the change of the height, excuse me, with respect to time. So dH dt equals 0.8 feet per second. And once again, we still know our base is 18 feet squared. Now, just looking back at this part of the problem, we understand that dV dt right here equals base times dH dt. We can pretty much use that same exact equation here because we're still on the same problem and nothing's really changed. We're just given the opposite. Last time we were given dV dt, this time we're given dH dt. So dV dt equals base times dH dt. dV dt equals, now we just plug in our values, 18 feet squared times 0.8 feet per minute. You get dV dt equals 14.4 feet cubed per minute. Again, we know it's feet cubed for two reasons. One, we're doing feet squared times feet in the numerator. And two, we should be getting feet cubed because we are calculating volume. Or rather, whatever the unit of measurement we are using, that unit of measurement cubed. So it could be centimeters cubed, meters cubed, feet, inches cubed, whatever. And because we are calculating that change with respect to time, it's going to be over minutes. But we also know that we were already multiplying by minutes in the denominator, so yeah. So I know not all of my tutorials are exactly 6 minutes, but sometimes I go over, and hopefully that's fine with you guys. As long as you guys are understanding. If I'm not clear, please let me know and I'll try and help you either in the comments or by remaking the video. So hopefully this helped, and thank you for watching.